Hi everyone, and welcome to today's session. Now, I am really excited because what we're going to be having a look at today is one of the three different types of plate margin. Now, all you are going to need for this session is a pen and a pencil. No, a pen, a pencil, and a piece of paper, sorry. And what I would ask, please, is before we start the session, turn your phone off, hide it under your bed, make sure it isn't a distraction, shut your bedroom door, and then let's crack on and have a really good session. Okay, so our title for today's session is this: why do tectonic hazards occur on constructive plate margins? Now, there are actually three different types of tectonic plate boundary, but today's session, we're just going to focus on this one, a constructive plate margin. So please can I ask you to write the title? It's a question, so it's going to need a question mark on the end. Underline it to make it look beautiful, and then let's crack on. Okay, so the first thing that I would like you to do today is to have a look at the map. Now, the map shows us, it's really zoomed in on the North American plate and the Pacific plate, the Cocos plate, the Nazca plate, the Caribbean plate, and the South American plate. Now, you will see on that map that there are different arrows that are pointing either towards each other, away from each other, or alongside each other. Now, those arrows represent the three different types of tectonic plate boundary. Now, they are called constructive, destructive, and conservative. Now, I want you to say each of those after me, okay? Constructive, destructive, conservative. Now, you will have heard words like constructive before and destructive before. And the word constructive normally means to create something. If you are a construction worker, that means that you are building something, making something new. Whereas the word destructive normally means to destroy it. And actually, that's quite a good rule of thumb to follow when we're talking about tectonic plate boundaries. Now, in our session today, what we are going to be looking at is what's called a constructive plate boundary. And I want you to have a look at the map again, and I'd like you to have a look at where you can see the Cocos plate and the Nazca plate. And those two arrows are pointing away from each other. Now, that is a constructive plate margin. And now I'm going to explain exactly what that means. So, first of all, let's have a look at the photograph. Now, the photograph on the left-hand side is a photograph of a constructive plate margin in Iceland. Now, Iceland is incredible because actually, where you see the gap down the middle, that is a plate boundary. It's one of the only places on the earth where you can see a constructive margin this clearly. And essentially, the rock on the left-hand side and the rock on the right-hand side represent two different tectonic plates, the Eurasian plate and the North American plate. And they are moving apart. But what you can see here is that actually there isn't just a great big gap and a hole in the surface of the earth. There is some kind of dry rock material that's come up in the middle. And that represents our constructive margin. Now, let's have a look at the map that is on the right-hand side of your screen. And actually, can you see down the middle of the Atlantic Ocean, there is that sort of slightly dotted line. Now, that represents what we call the Atlantic Ridge. Now, the mid-Atlantic Ridge shows those two tectonic plates moving apart from each other. And essentially, Iceland is that little bit of land right at the top. And those two plates, the Eurasian, the North American plate, they are pulling apart. One day, Iceland will be two separate islands because of this. We're talking a very long time in the future, but one day it will be. Okay, so what we've got here is a diagram of a constructive plate margin. And I love this diagram because it helps us to revisit some prior learning. Now, if you have a look at the diagram, you can see that there are two yellow circles that are marked out with arrows. Now, I want you to have a really good think. What is that called? The plate tectonic theory that says that, that heat is being transferred from the core through the mantle, and then it causes these circular movements. What is that called? I can hear you thinking. I'm thinking. Good. For those of you that are screaming at the screen, convection currents, you are absolutely right. Now, in this case, you can also see from the great big blue arrows on the top that these plates are moving apart. And we can see that in the middle of the two plates, like we saw in the photograph, there is magma that's come up from the mantle, and that is forming new land. It's really, really exciting because literally new land is being formed. And also, that is where we get volcanoes. Now, they're a different type of volcano than the one you're probably used to. They're actually called shield volcanoes because they're not hugely eruptive and powerful. They're actually flatter and they have that kind of shield shape. So, at a constructive plate margin, the two tectonic plates are moving apart or diverging. Now, if you Google diagrams of this, the Americans would call this a diverging plate boundary, but we call it constructive in the UK. Now, magma rises up from the mantle to fill the gap, and when it cools, it forms new crust. So, if you would like to, pause the video now and just make some notes, and then let's crack on. Okay, so what I would like you to do now is to draw a diagram of a constructive plate margin. And what I've done is I've put a quite simple diagram up on the screen for you to have a look at. Now, the really key part of this diagram are the arrows that show plate 1 and plate 2 moving apart from each other. But there are some other arrows that I would like you to include. Can you include convection currents? So you can see the red arrows that shows that transfer of heat. Then can you include magma? Because that helps us to explain what is happening on the surface of the Earth. So those shield volcanoes that I mentioned. Add plate 1 and plate 2. And then let's use the specific name, so the mid-oceanic ridge. Now, give your diagram a title. Key thing, make sure your arrows are really clear. So it might be worth using a different color. And then let's carry on. Okay, so now we've had a look at what a constructive plate margin looks like and what is happening on it. We now need to think about why this creates a hazard for a human being. Why is it that actually we would consider an area that was near a constructive plate margin to be vulnerable to hazard risk? Now, the first thing that is important is that actually both volcanoes and earthquakes occur on this plate margin. Now, the volcanoes tend to be the more serious hazard, but there are some earthquakes as well. Now, volcanoes, what happens is magma rises up from the mantle into the gap. And then, as I say, we get these flat shield volcanoes that are formed. And then earthquakes happen because actually what sometimes happens is where those plates sort of crack, tension builds up as they move away from each other. Now, as I say, they're not normally major earthquakes, but it can happen. Now, what I would like you to do is to have a think about why volcanoes are hazardous. What is it that makes a volcano a risk to people and the economy and to the environment? Okay. So, why volcanoes are hazards? Now, the first thing that I'd like you to do is to have a look at this aerial photograph. And this aerial photograph is of the Icelandic volcano that erupted in 2010. Now, I'm about to pronounce the name of this volcano because I spent weeks trying to learn this. And it's Isla Gela Vietlafocal. Yeah, I've fluffed it. It's Isla Gela Vietlafocal. I would normally, if I didn't know how to write it in an exam, put the Icelandic volcano. Now, as you can see on that satellite photograph, there is a huge amount of ash, that dark grey colour that makes it into the sky. So why does that pose a hazard risk? Okay, so what I'm hoping is that you've been thinking about this. Ash clouds are hazardous because they disrupt air travel and it makes it dangerous for aeroplanes to fly. Now, after the eruption of the Icelandic volcano in 2010, aeroplanes were not allowed to fly across Europe for 5 days. And that's because it's dangerous. The ash can get into the engine of the plane and cause it to crash. That is definitely a hazard. So the second problem is that actually the ash can cover farmland and that can destroy the crops underneath. And that's exactly what happened in Iceland after this eruption. And the third problem is this. Sometimes there is so much ash that when it falls on the roofs of buildings, they can actually collapse. The weight of the ash will collapse those buildings. Now, it is definitely worth pausing the video now and taking a note of why volcanoes are hazards and why it is that ash clouds are hazardous. Because whenever you are asked about the processes that relate to constructive plate margins, there's every chance they will then link that to why that then is a hazard for a human being or for human population. Okay, so let's have a look. What are the hazards that we associate with earthquakes? Now, earthquakes are very different. Earthquakes occur and the ground shakes. So have a look at the picture that you can see. What is the hazard there? And this is literally a say what you see. Okay, so I'm hoping some of you are saying, well, the building's collapsed, the roof has collapsed. If you have, you are absolutely spot on. So this photograph was actually taken after the 2010 earthquake, which took place in Christchurch in New Zealand. And the earthquakes are hazardous because the ground shakes, causing buildings to collapse. And often water and gas pipes can get damaged, which causes fire and floods. Now, there are lots of other reasons why earthquakes are hazardous, but those are the key two. So again, if I was you, I would pause the video now and just make a note about why earthquakes are hazardous. Okay, so this is what we've been building up to. And this is a fairly complicated question that I'm going to ask you to answer. Now, stick with me, because although the question seems long, actually, if we break it down piece by piece, then you can do this quite easily. And I've put some success criteria on the board we'll go through, or on the screen, sorry, that we'll go through in just a second. So the question is, using the map below and your own understanding, suggest how plate movements cause tectonic hazards in Iceland. So the first thing that we need to do is use the map below. Now, if it was me, I would name that specific plate boundary. So we've got the two arrows moving apart. So that identifies it as a constructive plate margin. Then we need to refer to the map. And actually, we can see the fact that it's the North American plate that is moving away from the Eurasian plate. That detail shows that you have used the map. Then, and this is where this question is so sneaky, it says, suggest how plate movements have caused tectonic hazards, not caused a tectonic hazard. This is essentially a plural. So they are asking you, about how constructive plate margins cause both volcanoes and earthquakes cause hazards. So this is a long answer. Break it down. Have a starter paragraph where you name the boundary and refer to the map. Then I would have one paragraph that explains why volcanoes are hazardous, and then one paragraph that explains why earthquakes are hazardous. Pause the video. If you need to, go back and watch previous sections, because everything we've done in the session today will help you to answer this question. And then do your best, okay? Okay, so, excuse me. So that was a big question. Let's go through the answer. Now, I think it would be really important, actually, if you had a highlighter or a different color here so that we can start to highlight some of the key terms in this answer so that you can see where you would have got the marks. So the map of Iceland shows the North American plate moving apart, and then I've shown off and I've written the word diverging, you don't need that, from the Eurasian plate. Now that would give you 1 mark. And the reason you get the mark is because you've referred to the map, which you were told to do in the question. And then this movement causes both volcanoes and earthquakes. Now remember, it was a sneaky question because it was a plural. It was asking you for 2 hazards. Now, here I am showing off some more geographical knowledge. So, shield volcanoes occur on constructive plate boundaries when magma rises up from the mantle into the gap. Volcanoes are hazardous because they erupt lava and ash, which can make air travel dangerous. So you can see the first part of that answer, I'm talking about why a constructive plate boundary, is a hazard, as in it has shield volcanoes. And then the second part of my answer is when I link it to the fact that this is hazardous to humans because it makes air travel dangerous. Okay, the next bit then, earthquakes can also occur when tension builds in the cracks as the plates move away from one another. 1 mark for that. Earthquakes are hazardous because they cause the ground to shake, which can lead to buildings collapsing. Now, it wouldn't be enough to say cause the ground to shake, because actually they're asking about why it's hazardous. So we've got to link it to the fact that this could cause buildings to collapse. Now, I appreciate that was a tricky question. You have worked mega hard today. Well done for getting that done. The key takeaway, constructive plate margins move apart, and there are earthquakes and volcanoes that occur on that margin. Okay, so we have had another great lesson. I am really proud of you, especially for sticking with that 6-mark answer. Now, what I would love for you to do, please, is to go through your answer and highlight any of the key things that you've learned today. So as I said before, really think about the fact on a constructive margin, the plates are moving apart and the earthquakes and volcanoes occur on that margin. Now, I hope you have a great week. I can't wait to see you next time.